All right, this is our question for this video. So our question is talking about the mean value theorem. That is question 1. It is talking about the mean value theorem. Just a minute. I change this to song. Okay. All right. State the mean value theorem for derivatives. So mean value theorem, which is talking about derivatives. So now, to state, it's just like to recite. There is something you have mastered and then you're now just saying it the way it was mastered. That is about stating. Alright, we shall do that. Next question is talking about to prove the theorem you have stated. It's like you have said something. Now, show how it came about. It's like to derive, but through the state. See, find the point C in the interval 2, 5 with respect to f of x equal 2x squared minus 7x plus 10, satisfying the mean value theorem. So now, these things don't just come about. It's coming as a result of you stating it. So in your state, like I said in the previous question or video about conics, part 1 of our lesson this year 2026, I said you are a person who is ready for the exam, and now the exam has come and you're still ready. So these questions are coming to you who is ready. You know these things. You were taught or you taught yourself. That's why this question has come. So when they say find C, you can't see C here, but you have to find it. Meaning you have something related to that C. So that is this question. I believe we are together. We have question 2. Question 2 is talking about the function f of x to equal x power 3 minus 7x plus 6. So there is another theorem. That theorem was about mean value theorem, but this theorem is about Rolle's theorem. So now verify. So when they say Rolle's theorem, they're not talking about, they're not talking to a person who is not ready for the exam. They're talking about the person who is ready for the exam. So the person knows what it means. Okay? If that theorem is satisfied, then they're asking you again to find C. So now you can see that the mean value theorem talks about C. Rolle's theorem is also talking about C. So there's this C which you have to find. Whether you're in a mean value theorem or you are in a Rolle's theorem, that C exists in both. So make sure you know what the mean value theorem is about and you know what Rolle's theorem is about. Alright. So in case you are playing the video and then you're not seeing any writings but the voice, just know that I was explaining something important, that which is not given in your class, but important. Okay, let's start with the first question. So the first question is talking about the mean value theorem. So we have to state it. So do not forget the questions. So it would be good you have the questions with you. Okay, here is the state. I'll write it, then I'll explain it so that I don't confuse the two. I may forget as I'm explaining whilst writing. So first I'll write the theorem and then I'll explain it to you because you need explanation about it. All right. So this has to be mastered. Umuntu alefwaika as HBF. You need to master this. So if you can read it together, if the function, that's a state. So if you are stating, you always indicate that you are stating. Because when you reach fourth year, there is what we call state and proof. Proving and stating are different. So this is a state. So you indicate there, I'm stating. So now, if the function is continuous on a comma b. So now, you can see those brackets, they are box brackets. So the box brackets, they indicate that it is closed brackets. It's a closed interval, which means you are starting from A and you are ending on B. That is what closed brackets indicate. You are starting from A and you are ending on B. And differentiable on open, these are called open intervals, which are just curled brackets. Then there exists at least one point C in the open interval. In the open interval means it is between A and B. It is between what? A and B. Such that when you differentiate the function and replace the C, you are expected to have f of B minus f of A, everything divided by A minus B. So that is the case. I think I've talked about the brackets, the difference between these two brackets. This one means you're starting from A and you're ending on B. This one means in between A and B. Any problems? I guess you've got no problem. That's the case. So for the mean value theorem, this is what we rely on. And then that is our case. So now we are going to a remote tactical question. So now this question has been handled. Question A. We have done question A, which is talking about state. Now the next part that we're going to talk about is the proof. Prove the theorem you have stated in A. So what are we proving? We are going to indicate that this one exists. So in short, we need to come up with this. That is question B. We need to come up with this. No matter what we go through, let's come up with that. Whether then I pen and pen, let's try by all means. We go and find the mean value theorem. Okay. This is how we start. It's a bit tactical, but I trust you. Your brain is now very active after doing a lot of mathematics. You can follow through. So I'm going to indicate something that you can follow. Okay, this is how we begin. B. We're talking about the proof. Right? So let's just say proof. Okay, so we begin. Suppose we have a function f of x. We have just said we have this function. So now, as we explain, let's relate this. Let's relate it to what we know about the mean value theorem. How should that function be if it's under mean value theorem? It should be what? Continuous, and it should be differentiable. Where should it be continuous? On the closed interval. What does closed interval mean? You are starting on the first point and ending on the last point. And where should it be differentiable? It should be differentiable on the open interval. What does open interval mean? You are starting after the first and ending just before the last. Okay, continuous, what does it mean? It means when you have got a function, whatever value you are going to put there, it is going to give you an answer. Then it is continuous. That's the meaning of continuous. If there is a function and it is termed to be continuous, meaning whatever value from the interval given, if you put it there, it is going to give you the answer. Then it is what? Continuous. If it is differentiable, what does it mean? If there is a function, first differentiate it, and then follow the interval you have been given, and then if you replace a value, you are getting an answer. Then it is what? differentiable. I think I've explained those two. Okay, so now let's start. Suppose we have a function f of x that is continuous. That is continuous on and differentiable on. So that is what we have. We have a function f of x, and that function is so that's how we write the proof. You write, even the words I'm writing, you write. Mathematics is not always about calculating. At times it's about concepts. Writing my theory. No calculations involved. You're just writing my words. No calculations being involved, but just explaining like that. That's how at times mathematics go. Okay. We need points. We need points, the starting point and the ending point. Remember here we have got A, comma B. So even for us, let's consider our starting point. We're going to call it A. But this point, okay, we use points. We use points. Which points? Let's use A and f of A as our first point. And then the other point, we're going to use B and what? F of B. So these are the points we're going to use. So this one is acting like A because murima A. And then this one is acting like what? B because there are B's there. So that's about it. And then we use the points, this one and this one, to find M. M, which we call what? Gradient. To find gradient. Gradient is just the rate of change. That is what we call what? Gradient. Gradient is just the rate of change. Okay. We know that when you're finding gradient, it's about change in y over change in what? X. All right. So that's that one. So in our case, we have a point. The first point is this one. And the other point is what? This one. So this one we're going to call it x1. This one we're going to call it y1. This we're going to call it x2. This one we're going to call it what? y2. We know a point is always x, y. So if we are talking this one to be a first point, we say my 1s. If you're saying this is a second point, you put my 2s. That's why I'm putting my 2s and my x there. Okay, let's continue from there and let's now find m. So what is m? M, we said this y2. What is our y2? Y2 was f of b minus y1. Our y1 was the f of a over x2 was b. Then x1 was what? A. So that is our case. So I'm just referring to this. This was x1 and I've put x1, y1, x2, y2. The formula is saying y2 minus y1. That's why I've taken this one to be there minus the other one. So it's just about the formula and how you named them. That's the case. So when you're proving something, you need to have the idea of what you're proving. So that's why I've said this should be my 2s, because I know there is some subtraction. And in our proof, B is always subtracted by the A's. So I cannot put these ones as 1s. No, these will not go well. Alright, we continue from there. What's the next thing now? We need a new function. Ka function taka simple which should be a difference between a certain line, which we call the second line, and the f of x. So we define. That's what whatever you are seeing writing here should be written when you are in the exam. We define a new function g of x. this function, it is going to be a difference between the second line and f of x, which is a difference. Difference means subtraction. A difference between f of x and second line, which is given by y equals f of a plus m x minus a. So that is the case. So that's our case. We define a new function g of x. This g of x, it's a difference between who? F of x and second line. Who is second line? Second line is given by what? F of a plus m multiplied by x minus a. So you know this mathematics at times, we just learn a part of our next level of mathematics. So when we look at such equations like this, for the sake of success, we just need to master such things. Things like a proof. At times, you may say, but how did you know them? At times, just tell your brain to master these things. Then, as you keep on solving, you will now come, if you are too much into them, you will now start to find reasons why some of these things exist. Like when you look at this, if they tell you this is m and this is the formula, you may think of this is y2. First, you need to identify the equation. So it takes about, I think, interest. Yeah, interest. After interest, these things, they start to tell you themselves on their own. They'll just start telling you, I am x, I'm y2, my friend is y1. I'm x2, my friend is z. Because they relate exactly to the formula. So that's what I'm trying to talk about. So when you say second line, if you see f of a, m is there. This m, we know m and m. You see, m and m. So meaning this thing is going to be replaced there. All right. Let me not confuse you much. Let's stick to what we're talking about. So now, just from this statement, we are saying we define a new function who? G of x. Then people are saying, which is a difference? It is a difference between who? F of x and second line. You see? So this is what I'm trying to talk about. And then, from there, we can see that g of x equals f of what? F of x minus what? Minus y. So if you look at that, it's now next time of replacing. So let's try to replace g of x. F of x, we can't do anything there. Minus y, but y, we know the original y is this part. So in the place of y, we are going to put the entire thing here. This one, you can see y equals this. So we put this thing in the bracket there. Okay, let's just pretend we don't know what we're doing about m. So that's the thing. Then from there, let's now replace m. We can see this m. We know what m is about. You need a lot of energy for these things. I will understand if you don't understand on the first point, but you just have to understand before the exam. There are a lot of things we have to cover there, a lot. Thingy. Okay. As you can see, we have reached that part. So now, what does the Rolle's theorem talk about? That f of a should be equal to f of b. And then, we have not talked about Rolle's theorem yet. We did not state it. We did not state Rolle's theorem. But in the Rolle's theorem, there is something I can tell you about Rolle's theorem. What I can tell you is that f of a and f of b should be the same. That is about Rolle's theorem. So, the only problem that we have there, it's a x. So, let x be equal to a, and at one point let it be equal to what? To b. and check if f of a will be equal to what? F of b, and all of them should be giving you what? Zeros. So that is under Rolle's theorem. So Rolle's theorem talks about this point, but this point can only come in if your function you replace there with your a, again you replace your what? Your b, so that you see that both of them are giving you what? 0. Both of them are giving you what? 0. So let's test that point. It's in the state for Rolle's theorem. So let's test. Let's our x become with a, and then let it be what? A b. Then if you replace here g of a, where there is x, you're going to put a. That's what I'm trying to talk about. Here we're going to put a. Hi. But our case, we are not using f. So here we're going to use what? G. Pardon me on this one. Our starting function is what matters. Starting function. So in our starting function, we are dealing with g. So that's why I've changed the f to g. So x becomes a. Find the answer. Again, the x becomes what? B. Find the answer. Both of them should be equal, and that equalness is a 0. In short, g of a should produce a 0. G of b should also produce what? A 0. For you to be easier in the exam, you don't have to explain the way I'm explaining, but just mastering the proof. I'm sure this one can come. Okay, let's replace and see what we are going to come up with. So g of a, here where there is xi, everywhere put what? A, everywhere. So I'll just write g of x again here. Okay, you may ask me, guys, why have you gone back to m? I know in here there is no x, so I can just use m. In my proof for x equals a and x equals b, there is no x here, it's just a constant thing. So I've just gone back to this one so that in writing becomes simpler, but I know I'm talking about this. So I'm using x equals what? A. So g of a equals f of what? A minus mukatumu f of a plus m, where there is x we're putting a minus a. How much do I change that? They know that this thing, whether it's m or it's that function, is still, because a minus a is what? A 0. So this part is producing a 0. Why? A minus a is 0. 0 times anything is 0. So I'm just going to remain with this one. So g of a equals f of a times a minus, inside here it's a 0. What is remaining? F of a minus. So we can see that g of a has produced what? A 0. We have seen it. So now using the same function now, let x become now a b, and then you replace there. So it will be g of now b. There again we put f of b minus f of a plus m. Then now here we said okay, maybe is that going to make sense? No, it can't. We're going to put b there minus this one. Okay, so this is what we have as our case. Okay, I'm trying to see if we can come up with a 0. Okay, I think it's now time to bring back that guy. So f of b, this is what we have here, f of a plus, so now that m, I want just to bring back, because I'm seeing a purpose for that one. You've seen this part, this one. M. I said M is this. So I was using this because in the first part I didn't see the purpose of using this. But here I can see something here. We have put a B there, remember? See, we have put a B here. Alright, let me not confuse you. We are saying this is our function. Hi. Now we are replacing where there is x with it, B in our case. So here we have put B. Here we have put B. And here we have put B. And this is where we are here. So now, here, instead of putting M, I'm replacing back the theta thing, this thing. And it was over B minus what? A. That's what I'm saying. This is what is on the board. So this thing and this thing, they can cancel out. They are dividing each other. That's my point. Then now we are going to come up with f of b outside minus inside here we have f of a, and there is another f of a here, and then there is f of b. So what have I done inside? This thing is gone, this one is gone. I've just rearranged here. F of a plus f of b plus f of a, or minus f of a. F of a plus f of b minus f of a. I've just put this minus to start here. This one. F of a, I've put it here. Instead of writing f of b, I've written the last one. Why? I want these two to cancel out each other. Because f of a minus f of b, it's a 0. Then I'll remain with f of b inside. So g of b equals f of b. Then here it's a 0. Minus the last one. So g of, so that's the case here now. So now we can see that f of a, g of a gave us a 0. G of b has also given us a 0. Meaning g of a equals g of b, and they have all produced what? Zeros. So now, if that is the case, then now differentiate, find the derivative. Find the what? Derivative. That function g of x, the long one. Which long one? G of x equals f of x minus f of a minus there was a plus. Let me just refer to the, okay, we are here, we're trying to talk about this one. Where is the original Orijaba? Where are you, Mr. Orijaba? Okay, we're talking about this one. G of x, this function now. That's what we have here. So here we have a minus, plus, okay. So this function now, find the derivative in terms of x. So wherever there is x, differentiate. So when you differentiate, I know by now you know what it means. You just put a prime there. Whatever function is having x, just put a prime, means it has been differentiated. Where there is no x, the answer is 0. Where there is no x, the answer is 0. Here there is no x, the answer becomes a 0 inside. Why is there a 0? There is no x. Why is there a 0? There is no x. Plus this thing, they are together, they are attached. So the guy has got x there inside. So this part now maintains. Since it's a constant, it will maintain. You can't say there is no x. No, they are together, they are multiplying. So if you differentiate here, the answer is 1 minus what? 0. This part has no x. This part has no x. So here there is x, the answer is 1. This other part has no x, the answer is what? 0. This thing, you can't attack it. Reason, it is being multiplied with something having x. I've explained there. This thing cannot, you don't differentiate here because it is multiplying with a part having x. So go to the part having x and differentiate it. This thing you don't eliminate to say it's a 0. Why? It is being multiplied with a part having x. So go to the part having x and what? Differentiate in that part. So we have differentiated here and then we have differentiated there. This part has become a 0. There is a minus here, so this minus we have put it here. This part is a 0, meaning you just write 1 minus 0, 1 y times this thing would be it. So this type of mathematics deals with the mental. Brain no calculator. So 0 means forget. This part you maintain and then multiply by what is coming from here, which is a 1, meaning the part yara fin. So this negative has not worked. Now when you're proving this one, we know there is a concept which talks about g prime of c becoming a 0. This situation, g prime becoming a what? A 0. G prime of c. So this means that let your x become a what? A c. So if your x becomes a c, then this thing should be a 0. There is a concept here. The concept is saying let g of x become a 0. Let g of x become a 0, but that x should become a what? A c. So that is the concept there. So it is this part. So in the part of g of x, let the x become a what? A 0. So this part you convert it first to c. You are going to use this. So that is the case. Now this part, let it become what? A 0. Do not change this x. Do not change this x. But if we refer to Roll's theorem, there is a part which talks about, what is that? The mean value theorem which we talked about. The mean value theorem, it talks about this guy also being a, when it's a prime and you replace c. So that now qualifies us. Let's just use this point. Yeah. So let the x become, yeah. Let this point be valid. So that is the case there. Okay, we have said let x become a 0, or let x become a c. And then this guy should become a 0. So x, wherever there was x, we have put a 0. That's a point. And then now this guy, wherever there is g of c, let it become a 0. This whole thing is in the Roll's theorem. So once you understand the Roll's theorem, the state is safe. So we're going to have a 0 this side, and then now make this the subject, because you're proving. What are you proving? Mean value theorem. Where is the mean value theorem? We stated it. I don't even know where I put the paper for the mean value theorem which we stated. Okay, we started it, and it says this thing is moving this side. This thing, it's having a negative. So if you check on the state, f prime of c starts. This thing has moved the other side, so it has become positive. This one is still positive. which we have written. This thing, when it goes the other side, it becomes positive also. So that is as required. This is what was needed to be proved. So that is our case there. Okay, thank you very much. As we look for the other part, as you can see, our question wanted the state, we have stated it, and it wanted the proof, we have proved. Now we need to solve. So I think of creating a separate video for the solving.